Hello, welcome to Al Jalin's Prep Academy. Today we're going to go over ratio test. Ratio test is a test used to solve for convergence or divergence of a function a of n. This can be seen as limit as n approaches infinity of absolute value a n plus 1 over a of n. Ratio test is represented as limit as n approaches infinity of absolute value a n plus 1 over a of n for the series a of n. If limit as n approaches infinity of a of n plus 1 over a of n equals L, which is less than 1, then the series of a of n is convergent. If the limit as n approaches infinity equals L, which is greater than 1, then the series of a of n is divergent. And if the limit as n approaches infinity equals L, which is equal to 1, then the series of a of n is inconclusive.
Let's look at example 1. We have the series of 2 to the n over 3 to the n, and we want to determine whether it converges or diverges. Start by taking the limit as n approaches infinity of 2 to the n plus 1 over 3 to the n plus 1 times the reciprocal of 3 to the n times 2 to the n, all in absolute value brackets. We cross multiply and simplify to get the absolute value of 2/3. 2/3 is less than 1. Therefore, the series of 2 to the n over 3 to the n converges by the ratio test because L is less than 1 and 2/3 is also less than 1.
For example 2, let's try the summation from n equals 1 to infinity of n times 3 to the power of n over n plus 2. To find whether this converges or diverges, we have to take the ratio test, which is the limit as n approaches infinity of a of n plus 1 over a of n. Doing so, we can basically add a plus 1 to every n in our equation and multiply this by the flipped version of the equation. Doing so, we get limit as n approaches infinity of n plus 1 times 3 to the power of n over n plus 3 times n plus 2 over n times 3 to the power of n. Simplifying, we get the limit as n approaches infinity of 3 times n plus 1 times n plus 2 over n times n plus 3. Because we're going to infinity as limit n approaches infinity, these values that include the n's and the plus 1s, plus 2s, and plus 3s basically go to infinity. So we get 3 times infinity over infinity, which is equal to 1, which is equal to 3, which is greater than 1. As such, this diverges by the ratio test.
For example 3, we have the series 1 over n. To find out if it converges or diverges, we start by taking the limit as n approaches infinity of 1 over n plus 1 divided by 1 over n in absolute value brackets. It can be rewritten as the reciprocal times 1 over n plus 1. After cross multiplying, we plug in infinity into n, giving us infinity over infinity, which is equal to 1. 1 is equal to L, which is equal to 1. Therefore, the ratio test yields an inconclusive result, and a different method has to be used.
Hey, we're your tutors, Marco, Prince, Ollie, and Sam. If you enjoyed our video, feel free to hit the like button below, or subscribe to our channel. Once again, thanks for watching Al Jalin's Prep Academy.